Hello, and thank you for joining today's webinar. I'm Lucy Hodes, Senior Vice President of Media and Communications for CCA, and I will be your moderator. Hope everybody's doing well. Today's webinar is Private 5G Network Deployment Use Cases, and it's sponsored by Radisys. Our presenter is Rishi Maulick, who is Director of Product Management and Business Development at Radisys. Rishi focuses on the company's mobility access technologies, and he works directly with service providers to re-architect and move their networks to open software-centric architectures. He joined Radisys in 2013 after holding engineering positions with Continuous Computing and YPro Technologies. We're glad to have him with us today. For those of you in the audience, if you have any questions throughout the presentation, please submit them at any time and we will get to questions at the very end. Also, just want to mention that today's webinar is being recorded and it will be available on the CCA website when it's over. And now, Rishi, I will turn it over to you.
Thanks, Lucy. Hello, everyone. Lucy has already introduced me, so we'll straight get on to business. Today, we are all here to discuss about 5G network deployment and the various use cases. Plus, more importantly, the synergies between traditional, LTE, 3G, 2G wireless technologies with respect to 3GPP, and how, the evolution is coming with 5G across cloud nativeness, across edge computation, and how do we'll be talking about how are we going to bring in, the aspect of public versus private wireless technologies involving 5G. With that, the quick three topics that we're going to cover as part of today's agenda. First of all, obviously a quick recap on 5G, and in this section we'll be basically going through the details of how different is 5G from traditional wireless technologies, from deployment, from architecture, and even the lower levels of nuances from a technology perspective. The second section for this agenda is obviously the specific topic about the typical deployment use cases that we are definitely seeing from service providers, our customer bases, our OEMs and ODMs, which are really summarized into four distinctive areas. The first one being industrial automation or IIoT. Which is definitely synergetic with respect to private 5G. The second aspect, very prevalent within here in the Northern America, and also getting a lot of traction in the other parts of the world, is about unlicensed spectrum and how that is synergetic with respect to private 5G. The third aspect is, of course, about edge computation. MEC has been around for quite some time now, starting from the LTE days as well. But more and more as private 5G is coming to the forefront, edge computation is actually getting its technical manifestation to be deployed from a private 5G perspective. And lastly, network slicing, which is an inherent architectural enablement from 5G, and then how would that intersect with private 5G. And the last section would be a bit of a briefing and summary of what Radisys has as an offering in the space of 5G new radio. And we'll be going through those details of what do we have from a mobility access business unit. With that said, let's quickly go to the quick recap of 5G. Of course, when we look at the traditional or the previous generations of wireless technologies, 3G and 4G, pretty much, these were all designed and architected for one majority or one major use case, which was, enabling mobile broadband. And with 5G coming into the picture, the new radio or the architecture of this technology itself has given the manifestation to very distinctive three use cases or three functional areas. One which is existing enhanced mobile broadband, where we are talking about much higher throughputs than what is traditionally observed in LTE or 3G wireless technologies. The second is obviously URLLC or ultra reliable low latency, and those kind of lower latency communications, which is a very distinctive use case with respect to 5G, where we are talking about how do we ensure that we are able to provide higher data throughputs in the uplink side of things, also with a much more lower latency, from an end-to-end communication perspective. And then the third aspect of 5G is massive machine communication, which is where a lot of this industrial IoT aspects are coming into picture. Now, these three are very distinctive, unique use cases. However, 5G is actually an intersect of all these three use cases. Obviously, when we are talking about these three use cases, critically, we are looking at three technical requirements in a broader term. The first one is obviously, higher throughputs, which is where enhanced mobile broadband is coming into the picture. And the moment we have enhanced throughputs or higher data, fatter pipe, this basically gives way to a unique, wider or newer variety of devices, not just regular handsets, but now we are talking about remote cameras, we are talking about V2X, we are talking about connected cars, we are talking about assembly line within industries for automation, and so on and so forth. The second is obviously lower latency applications. This is very critical from these mission critical devices like connected robots. These are being used for connected cars. These are being used for medical and healthcare applications, for example, remote surgeries and stuff like that. And lastly, 5G is all about a new radio. So there are obviously some very basic changes from LTE and 4G standards. Beamforming is one of those critical aspects, and as well as massive MIMO that is coming into more and more into the foreground. And these are very, very critical aspects, specifically beamforming, which enables uh, providers like us to think about connecting all these new devices like connected drones, a network in a box. We are talking about different sort of mobile broadband and point-to-point connectivity, and as well as point to multi-point connectivity with 5G coming into the picture. So this, in a nutshell, is a quick recap of the various areas. Now it's very important for us to have this as a beginning to the rest of the slide and the rest of the material, because we'll be on and off talking about all these three different categories between all those use cases that we'll be going through. Quick thing between public 5G and private 5G. Now, what really is private 5G versus public 5G? Now, when we look at public 5G, and this is also very, very critical based on how the architecture has been defined for 5G networks. Now, when we talk about public 5G, this is basically generally available to users like everybody, like of us, like the existing end users who have these handheld devices or the cell phones that we typically use. Now, there is already an existing infrastructure of 4G which is available right now with all operators. So public 5G is more focused towards non-standalone operation of 5G, where service providers are also looking at leveraging what existing infrastructure that is already deployed on LT, use that as a master eNode B or as an anchor to very quickly provide 5G services to end users like us. Now, these are typically wide area deployments with their existing radio vendors, radio ecosystems, which are mostly LTE and 4G based. And at the same time, in a pragmatic manner, the 5G ecosystem is coming in, the 5G radios are coming in. But in a nutshell, public 5G is, I would say, is almost equivalent to non-standalone mode of 5G. And this is purely our view of seeing things. We'll be happy to open up the discussions at the end of this material. Now, if we go to private 5G, that's altogether a different ball game. Uh, and again, this is coming in from the inherent architecture of 5G, which is going to enable all these different uber cool applications of dynamic slicing, dedicated bandwidths. When we talk about private 5G, we are really talking about a very close knit enterprise access or an industrial IoT access or a factory site where 5G as a wireless technology is basically enabling all those different operational benefits that typically would be required in enterprises or in factories or in industries. Now, private 5G basically gives the enablement for such kind of independent network design and management, which will basically drive at the end operational benefits to such kind of factories and enterprises that are leveraging 5G for their purposes. Very important point here with respect to private 5G when we talk about public 5G in a comparative manner is private 5G is actually enabling deployments of standalone mode of 5G where there is no dependency on any existing 4G infrastructure because these will be mostly greenfield. So these enterprises, these factories can actually host and install and operate with standalone mode of 5G, where everything is with respect to the new radio, and as well as the core network functionalities are also brought in from the new 5G core network, which is based on service-based architecture. So private 5G actually gives the opportunity to bring in standalone mode of 5G operations in parallel to a non-standalone mode of operation that's working predominantly for the public 5G sectors. The next sections are obviously, the intersects and synergies between private 5G and the various use cases of deployment that we're looking at. The first and the most prevalent one that at least we are definitely, observing is industrial automation. This is where, Industry 4.0 becomes very, very critical. And from those three unique areas that we were discussing in the first slide about MMTC, industrial IoT, enhanced mobile broadband, and URLLC, two of them definitely finds their place here, which is URLLC to begin with, and the second one is obviously industrial IoT or massive machine type communications. A critical thing to note here, which is obviously different from traditional LTE and 3G days, is 5G is actually a vehicle of providing information and connectivity to these end devices, which are not standard handsets. These are robotic arms, these are assembly lines, these are automated guided vehicles. And then the intersect with Industry 4.0, where with such kind of an assembly line, we are really looking at how do we enhance and bring in the agility into the operational tech for Industry 4.0, which is a critical key aspect of Industry 4.0. From a technological perspective, what's available from 5G and all the other standard bodies, is obviously URLLC. So Release 16 is already out. Ultra reliable lower latency features and functions, mini slots, mini OFDM symbols. These are coming into the development cycles of such providers like Radisys. Another aspect is time sensitive network or TSN. There are some newer nodes and newer network functions which are being defined by 3GPP in order to ensure that lower latency and reliability is ensured from an end-to-end perspective, not just from individual network functions. So this all has to work in unison from an end-to-end perspective, as you can see on the figure where a factory use case is being shown. It starts from the supply management, goes through automated guided vehicles, it goes through the assembly line, and these all have wireless connectivity to ensure that their regular operations are working seamlessly and in a much effective manner than they used to work before. And then you can see these robot motion controls. There are a wide variety of applications for such things. And then finally, the delivery management. So right from supply management till the delivery management, all of these are tracked over wireless access, which is being enabled by private 5G. Another critical aspect here is 5G or 3GPP being the main governing body across wireless technologies, and 5G is definitely no different from that, is actually looking at lot more innovative data plane mechanisms than the traditional GTP based data planes, where things like time sensitive networks are coming in, things like Ethernet PDUs are coming in, because typically these robotic arms, they don't have full-fledged IP stack. So in such cases, having a traditional data plane doesn't or will not work out that smoothly, and in such cases there is a definite need for thinking out of the box and bringing in some more innovative data plane mechanisms. So Ethernet PDU is one of those innovative data plane mechanisms where the payload, which obviously is completely transparent to 3GPP network functions or wireless network functions, are actually padded onto Ethernet headers than going into the typical IP headers. And such kind of data plane mechanisms are being enabled specifically for industrial automation and factory use cases. Now, this definitely is synergetic with respect to private 5G, where industry bodies, factories can look at standalone mode of operation. They can install and commission a full-fledged 5G system in a greenfield like deployment mode, not depending on any existing older 4G infrastructure. And this is all going to be private 5G with standalone 5G core, end-to-end providing ultra reliable and lower latencies. So that's the intersect of private 5G with respect to industrial automation and factory use cases. The second use case, as I was mentioning earlier, is obviously about intersects of private 5G with unlicensed spectrum. At least here in the Northern America, this has definitely been very critical, and there's a huge momentum and traction on this. In fact, there are already some early deployments, commercial deployments that have already happened with CBRS or Citizen Band Radio System. This is basically a mid-band spectrum between 3.5 to 3.7 gigahertz. And fortunately, or in fact, this is where the intersect with private 5G comes in, because 5G operates in two frequency modes, sub-6 and millimeter wave. Now, FR1 or sub-6 is a sub-6 frequency range, which aligns with the CBRS unlicensed spectrum frequency ranges as well, thereby enabling the service providers or whoever is using unlicensed spectrum, even the enterprises or in building operations, to be leveraging 5G spectrum, 5G new radio, but in a complete greenfield deployment mode, in a standalone mode, not in a non-standalone mode. So there is no 4G infrastructure whatsoever required for these. And further on top of that, CBRS is altogether a different standard, which has been blessed by FCC and all the other bodies within the Northern America, where there are tiered access which are provided to users of this spectrum. Obviously, the first tier is the incumbents. That's the DoD applications which are there for this unused spectrum. But then there is PAL or priority access leverage, and then there is GAA, which is general authorized access, that's made available to use cases like education, use cases like hospitality, healthcare, enterprises, or for that matter, even public spaces where there are some arenas, there are some basketball stadiums which are going on, and people would want to use the CBRS unlicensed spectrum for enhancing the impact of bringing in higher data rates, higher reliability, and lower latencies to their end users. Of course, industrial IoT is also part of the same. Basically, these are different use cases that could be used, but net is private 5G or standalone access of 5G new radio is synergetic with sub-6 FR1 CBRS spectrum. So this basically gives the opportunity to go into a very distinctive area and leverage what is already available without too much of nuances involved. The third aspect is obviously a much loaded term, MEC. There has been changes to this terminology as well. It started as MEC, mobile edge computation, then it became multi-access edge computation. But MEC is really a terminology, I would say, or I should say a technology, but this is not a protocol spec or something as such. Really what MEC is looking at is enablement of access, which could be wireless or wireline. It is enablement of the agilities of cloud nativeness, and then the economies of scale that comes in when we are moving into cloud native architectures. And the third aspect is all about edge computation, which is all about traffic processing. How do we ensure that the traffic which is actually being processed is not in a central CO or a centralized location, but brought in as close as possible to the end user, who is the actual recipient of that traffic, thereby enabling lower latencies, because at the end what we've achieved is a lower round trip time. And hence edge computation is very synergetic with respect to 5G, at least from a access perspective, which was the number one bucket. So 5G NR is going to provide the wireless access or means of wireless access to such MEC deployments. The second thing, which is cloud nativeness, is also equally important for MEC. So basically, with respect to MEC, we are looking at these typical edge sites. It could be a CRAN site or a Cloud RAN site. It could be a pre-aggregation site. It could be the IP aggregation site, based on the typical deployment models of service providers. But once we are very close to these sites, we do not have the luxury of bolting on huge honking data centers. So really, we are looking at a very optimized, 5G deployment with optimized infrastructure available or co-located at the edge sites. This is where cloud nativeness becomes very, very critical, because now we are really looking at slicing and dicing an available server or an infrastructure, and looking at how can we onboard containerized network functions. And the moment we have got into containerized network functions, we have the ability of leveraging all the benefits that come in from cloud nativeness, things like easier day zero installation, things like high availability, things like if something goes down, we have to replace that down pod or a Docker pod with a different Docker pod that is working, or in other words, high availability. Now, all of this is possible because 5G architecture inherently promotes the usage of containers, the usage of virtualization technologies, the usage of things like SRIOV that are very, very critical from a traffic processing perspective at the edge with an optimized infrastructure. So private 5G and edge computation are definitely synergetic, and there are lots of opportunities of bringing in again a standalone mode of private 5G with edge computation. When we are looking at use cases such as immersive applications, there's a lot of gaming applications that are coming into picture which are very much immersive in nature. So things like facial recognition for security purposes, augmented reality, virtual reality, which is definitely the next cool thing that's available to being made available to end users. Tactical applications which are location based, this is very, very critical when we are talking about service providers and 5G network, because apparently there are a lot of KPIs which are available within these network functions that are not exposed, thereby giving the service providers or whoever is providing 5G services the actual location, so that there could be billing implications based on such locations. And this is actually a very wide field because MEC is not just private 5G. People are also looking at MEC concept or bringing in MEC concept with public 5G as well. But the net is that 5G is definitely going to or has to work with edge computation, bringing in the benefits of cloud nativeness and virtualization. The last section on the private 5G is obviously network slicing. Now, inherently, the design and the architecture of the 5G end-to-end system has been so architected that there are very distinctive slices that are made available to end users that have varied, quality of service, quality of QCIs, or at least in terms of 5G QFI, which are distinctive on each of these slices. So basically, what 5G architecture has done is they have disaggregated the monolithic base station that used to traditionally be available, from the LTE days. Although there was some disaggregation in LTE, some could see the deployment benefits, but then that did not become very prevalent. But with 5G, at least for sure, there are multiple levels at which the architecture has been disaggregated, starting all the way from the split 7.2a on the front haul, where the physical layer or the most critical component of any base station or of any wireless technology, the layer one, that itself is disaggregated between hi-fi and lo-fi. And one of the unique key things why this was done is by segregating the fi between hi-fi and lo-fi, the lo-fi could be taken inside a radio, thereby rendering it as an ORU or an open RU, and the hi-fi could be seen as running as containers, bringing in the 5G cloud nativeness. Now, the moment cloud nativeness comes in, this becomes a candidate for an edge computation, because now you are looking at a much smaller infrastructure on which the layer one is actually hosted in a containerized form factor. So that is the first level of disaggregation. Then if we go further, the CU or the central unit of 5G, which is the non-real-time portion of the 5G base station, that is further disaggregated into CU-CP and CU-UP over the E2 interfaces, which is again very, very critical. Now, this gives us the benefit of scaling our user plane instances as many as possible, depending on what the use cases is, and having centralized smaller instances of control plane nodes, because it's really about scale but not about traffic. That's a control plane node. And then if we go further towards the core network, even within the core network, traditionally, we used to have in the LTE days or the 4G days, we used to have things like MMES gateway, P gateway, and then obviously the PCRF and the charging interfaces. But what 5G has done is within the core network functions itself, or the core modules of core network, that itself has been disaggregated, and very distinctive network functions or functionalities which were expected out of these three boxes have been further disaggregated, sliced and diced on the service-based architecture in the 5G core network. Why that is very important is, on those service-based architecture, there are lots of network functions which have been introduced in the 5G core. There is network exposure function, there is slice selection function, there is PCF, there is charging, etc., etc. Now, for a private 5G use case, not all these network functions would be required because you are looking at a very closed network which is private. It is not public, and this basically gives opportunity to think out of the box, think about innovative ways of how can we optimize these different network functions, at least on the core network, and use only that is required and not use anything which is not required at all. So basically it is giving the capability and it is enabling service providers to pick and choose exactly what they need, thereby rendering a very nimble operational module. Uh, Further on network slicing, these are all encompassing across these different deployment use cases. It could be healthcare, where there are some remote surgeries going on, and there is a specific slice of this 5G network function which is dedicated for such remote surgeries, where there are URLLC features available. Gaming, again, with respect to URLLC. When we are looking at V2X or autonomous vehicles, we are also looking at enabling a very specific slice of the 5G network that will enable these different autonomous vehicles, not just from the perspective of higher data throughput, fatter pipe for throughput, lower latencies, but then when this slice is very autonomous, you can then actually add in a lot of bells and whistles across management aspects. How do you do the day 0 to day 100 kind of usages of such specific slice, to be done in a very autonomous manner, not if impacting any existing 5G network functions. Industrial IoT is definitely also part of the same deployment use case, where we are talking about smart medical wearables, inventory management, smart metering, and the likes of it. So net the cloud nativeness of 5G is definitely fueling in automation, wherein people are looking at agile usages, bringing in CI/CD, the benefits of continuous integration, and then the inherent benefit of slice creation that is enabled by 5G as an architecture, enables the dynamic nature of creating slices to be required on demand to meet the real-time changing needs. I mean, you can create a slice as and when you need. You don't have to install and commission a slice right from day 0. Let's say at a certain point of time during the day, there is a peak traffic which is being observed by a particular service provider, which is really a data model. It's a data model. It's all driven through data model. 5G architecture is going to enable service providers to onboard a particular slice, taking care of that particular traffic of that particular time of the day on demand, not always available. So this actually gives a lot of flexibility and nimbleness to service providers to meet their end users' needs. Uh, that would kind of summarize most of the details that we had with respect to the different use cases from private 5G and the deployment use cases. Quick thing on the 5G and our offerings that Radisys has. I'll not take too much of time on these sections, but really wanted to share this information to people who already know Radisys and who are unaware of Radisys. So we've been in this business for close to about I would say 20 years now. We were part of Trillium Systems back in the late 1980s. We've gone through multiple companies, and although our base brand of Trillium is still the same, uh, and these are the various business divisions and business units that we provide in order to enable, integrate, and then at the end manage service provider requirements, starting all the way from endpoints, digital endpoints, which are the smartphones, the CPEs, or the handheld devices, enabling digital transformation for endpoints. We enable open and disaggregated access for both wireless and broadband access. Obviously, I'm related to the wireless side of things, and I'll be discussing about that more. But we do have solutions with respect to broadband access as well, which are open and disaggregated. We also provide communications with respect to real-time RTP and real-time processing, and as well as the 5G core. And last but not the least, network services, which is kind of a glue layer, which is combining all these three together to provide managed services to end-to-end lifecycle management, consulting, which are typically required for service providers. Specifically on the 5G NR on the wireless side of things, so Mobility Engine or Mobi is the business division that I'm part of. What's available from us on 5G side of things, as you can see here on the table, obviously this left-hand side figure is it's a 3GPP figure, pretty much widely known to everyone. The different disaggregated modules of 5G, the different splits and disaggregation that 3GPP has kind of blessed. And these are the three options which are most prevalent right now in the market in terms of 5G when we are talking about. And Mobility Engine inherently supports these three splits. So option 2, which is really a CU/DU split on the F1 interface. Option 6, which is more of a small cell like platform, millimeter wave solutions are definitely picking a lot of traction on this. And then option 7.2, which is what I was mentioning earlier, the front haul interface, the split A, where the physical layer is being split, thereby enabling, CPRI over Ethernet or radio over Ethernet for the front haul. That in a way is basically enabling cloud nativeness to be brought in on the DU side of things or 5G. Plus, we also have, the core network for both LTE and 5G available. This is a bit of an eye chart, a high-level view of the different architectures and what is available from Radisys. This is nothing new. It's all known. It's all 3GPP architecture. But really, we wanted to reiterate that in terms of those disaggregated network functions and those splits, we do have availability of CUCP control plane, then the CUUP, the user plane, and the user plane instances could be scaled up and down based on requirements. That's the reason why you see this figure here. And then of course the DU or the real-time portion of the base station that is also hosting the hi-fi or the physical layer itself if we are looking at an option 6 or a split 6 mode. Bit of an eye chart here with respect to what's available from a solutions offering on the features, both on the RAN and the core. We do have something called as a UE simulator as well. Now, this is a critical aspect for us because as 5G is evolving, the ecosystem is also evolving. But Radisys Mobility Engine as such does not want to be stringently tied to the ecosystem evolving. And hence what we have done is to ensure that we are able to demonstrate our capabilities. We have created some emulations and simulations that will be able to demonstrate our enhancements and our traction and pace on the G Node B side, on the base station side with these emulations. Although the ecosystem is definitely evolving, there are newer handsets which are coming to the market, and as and when they're coming, we anyways have integration streams going on. Plus, Radisys is a very critical part of all these different open consortiums and ecosystems. Obviously, starting from ORAN, which is very prevalent within the operator community. It's obviously started from as XRAN. We were part of XRAN as well. In fact, one of my colleagues is part of is a co-chair of one of these groups within ORAN. Small Cell Forum, of course, we are a contributing member within SCF, where we are, really looking at FAPI and how FAPI manifestations could be brought in from a 5G perspective. CBRS Alliance is a very critical aspect for us, very strategic for us. In fact, we provide the entire test suite within the OnGo certification for CBRS Alliance there. Obviously, we are part of Linux Foundation, Acreno from an Edge perspective. We do have portions of eComp as well as ONAP available with respect to our 5G solutions. Something very critical that we have joined last year, sometimes during Q1 or Q2, is the 5G ACIA. This is the European body for connected industries and automation. Very laser focused on industrial IoT as a use case with respect to private 5G, and there are lots of activities which are going on in this group. And then, of course, Telecom Infra Project, which is a marquee project or a marquee consortium, which is leading a lot of these open cellular, open RAN kind of deployment modes. Plus, of course, we are board members of ONF as well, which is another consortium that's really looking at bridging the gaps between wireless, wireline access, and bringing in the overall cloud nativeness. I think, yeah, that's all that I had for now. How are we doing, Lucy, on the time?
We're doing great. We've got just a couple minutes left for Q&A. So if you're ready to start that, we certainly can.
Absolutely. Yep. I think let's open up for Q&As now.
Great. Thank you. Just a reminder to those of you in the audience, if you have any questions, please go ahead and submit those. We have some that have come in so far, so we will jump right in. The first question, how do we see the 5G market evolving in terms of public versus private deployments?
Yeah, so very good question. Now, as I was mentioning earlier, so from our perspective, and this is purely that we are observing, for public 5G, most of the non-standalone mode of operations are being looked at, where there will be an LTE node as well available. It could be in a small cell form factor. It could be in a disaggregated form factor if there is availability there. But really, the LTE nodes, which are already available, these are all deployed infrastructure, would be acting as the master anchor node, and then the 5G new radio would be coming in for public access. Because generally the public 5G deployment use cases would be requiring, or operators are definitely trying to leverage their existing infrastructure, which is obviously very pragmatic. But very distinctively, when we look at private 5G, we are really looking at a standalone mode of operation, thereby enabling different 5G core networks, not leveraging anything which is traditional infrastructure available already. For example, LTE or 4G, even the EPC, or even the for that matter the LTE node B. So private 5G is all about standalone mode, and then public 5G is all about non-standalone mode.
Great, thank you. Our next question, how is 5G critical from an MEC perspective, and where are the intersects with private 5G?
Yeah, so from a mobile edge computation perspective, I think we were discussing about this earlier as well. So there are three critical aspects that would enable an MEC deployment. One is, obviously the access, which is where any wireless technology could be brought in, 2G, 3G, 4G, or whatever. It's basically providing a wireless access to the end users. 5G obviously is doing the job there from a wireless access perspective. Now, the two remaining items, which is very critical, that is brought in by 5G, is the first is the cloud nativeness. Now, 5G inherently as an architecture provides means of onboarding network functions in containerized form factors, which can thereby be onboarded onto optimized infrastructures that typically exist as MEC nodes. And the last aspect is all about data processing or traffic processing, thereby rendering lower round trip time for edge use cases, where 5G network slicing, you can have a UPF or a user plane function onboarded on the same edge infrastructure, and have the core network control plane entities being onboarded at a centralized location. So the network slicing, the cloud nativeness, and the basic wireless access, these three things combined together from a 5G perspective enables MEC.
Great, thank you. Looks like we have one additional question. So the next one, what are the different deployment choices and platforms being sought after with respect to sub-6 versus millimeter wave?
Yeah, so could you just repeat the question once again, Lucy?
Sure. What are the different deployment choices and platforms being sought after with respect to sub-6 versus millimeter wave?
Yes. So it's a bit of a contextual question, because we can only answer from what we are looking at and what we are observing. I can definitely confirm that when we are looking at sub-6 deployments, there are camps of service providers and our customer bases who are looking at the disaggregated mode of deployment, where you have a front haul, a 7.2 split, and also at standalone mode of operation rather than non-standalone mode of operation when we are talking about FR1. This is where synergies with CBRS or unlicensed spectrum would also come in. When we move to millimeter wave, millimeter wave is a 28 gigahertz spectrum, so there is line of sight issues and stuff like that, where most of the operators are looking at how do you cater to that inherent challenge, and thereby the resolution is to enable more number of arrays of antennas and small cells, thereby in millimeter wave, rendering a solution to this line of sight challenge. So millimeter wave deployments are more on a small cell like form factor that we are envisaging, and it is also with non-standalone mode. So millimeter wave is option 6, small cell deployment modes. Sub 6 is option 7.2, standalone mode deployments that we're looking at.
Great, thank you. Well, that concludes our Q&A portion of the webinar. Do you have any final thoughts before we close out today?
Not really. I hope I've been able to cover all the aspects and the critical ones which are definitely being sought out for with respect to public 5G and private 5G and all these different use cases. Full disclosure, 5G is still evolving. There's a lot of ecosystem enhancements that's happening, and Radisys mobility engine business unit is definitely one of the integral part of this overall ecosystem, be it radio, be it devices, be it different network functions, and we are happy to collaborate with one and all with respect to 5G.
Great, thank you so much, Rishi. Thank you, Radisys, for sponsoring today's webinar. That concludes our presentation, and I hope everyone has a great rest of the day. Thank you.
Thank you all.